Alright, so today we're going to be doing most of 5-7, solving polynomial equations. So when I say half, it's not exactly half, and I'll show you where we're going to leave off. It's just a certain section of it. So we are going to focus on solving polynomial equations, and then tomorrow we're going to deal with the difference in sum of cubes. That's something that's a completely new topic, so I want to do it on a day we have a little more time. So solving polynomial equations starts by factoring. Just like the factoring we've been learning about in this class, a lot of factoring that we did in Unit 2 applies here. So a lot of the strategies we're going to be using today to solve are going to be based off of factoring processes you've already learned. So not much of what we do today is new material. It's more of a review with an extra step added. So we're going to start by reviewing the GCF and the AC method, and we're going to talk about how it applies here. So, first thing you're going to do, yes. Yeah, we're going to do it, like I said, tomorrow. We'll come back to this tomorrow. Yeah, we're going to come back to this chart tomorrow. So, GCF and AC method. First thing you're going to do is you're going to subtract 3x to get everything to one side of the equation. So it's going to be 2x cubed minus 5x squared minus 3x is equal to 0. So you want to get everything to one side, and then you're going to look and see if there is a GCF. What do you think?
No.
No numerical GCF, but what about a variable?
X.
Yeah, we can factor out an x. Everyone see that? So this is a cubic polynomial, but we're factoring it into the product of a linear and a quadratic polynomial, right? So once we get to this stage, do you all remember, bless you, the AC method right here? So the AC method says if you have an A term in the front, you can multiply it by the last term and bring it over there. And then you're looking for factors of -6 that add up to -5. Any ideas?
-6 and 1.
Very good. -6 and +1. And once you do that, you then have to counteract the multiplication we did earlier by doing what operation? Division. Sometimes that number divides, and you're going to divide it. Sometimes it does not divide, and does anyone remember what you do with it?
You put it in front.
Very good, you put it in front. Okay, you do remember some stuff, so that's good. So this is where we kind of left off with it when you first learned about it. This is what's called the fully factored form. Now we're going to talk about how we apply this form to finding solutions. So we have three products here. Do you see that they're all being multiplied together? So this means we can apply what's called the zero product property, which we have learned about. And it states that if you have the product of any three expressions, and that product is equal to 0, you can set each one of those individual terms or expressions equal to 0, okay? So I'm going to set the x equal to 0. I'm going to set the x minus 3 equal to 0. And I'm going to set the 2x plus 1 equal to 0. Now the good news is about the first one is there's no additional solving required. One of those is just 0. This one here does require some solving. To get x by itself, we're going to have to add 3 to both sides, which then gives me x equals 3. Now for the next one, to get x by itself, we're going to subtract 1 on both sides. That's going to give me 2x is equal to -1. And then we divide both sides by 2, which gives me x equals -1/2. So these are our three zeros or solutions to our our cubic function. And as you can see here, do you see that the degree of this polynomial is 3? Which means that it should have yielded 3 solutions, which it did. So that's a way to kind of verify your work. Any questions about that? So that means,
Can you do the last one again?
sure, this one right here?
No, the one below that. The green one, the last exact thing you just said.
Oh, this right here. So you subtract 1 on both sides and then divide by 2.
Oh, okay, that's what I missed. Okay, thank you.
So that means that if you were to graph this on Desmos, this equation, you would have 3 x-intercepts that occur on these 3 numbers. Okay, that's how it applies to the graph. All right, moving on. For the next problem, we need to get it into standard form, which means we need to get the 9x to the other side. That leaves me with 3x cubed minus 6x squared minus 9x is equal to 0. And as you move things around, you also want to make sure that you maintain standard form by leaving it in descending degree order. Once you get to this step, you want to see if there is a GCF. What do you think?
3x.
Good, 3x. We're going to take out a 3x, and that's going to leave me with what we have here. Okay? Now, you don't need to use the AC method here because there is no a term in front of the x squared, so you can just factor it as normal. So you're looking for factors of -3 that add up to -2.
-3, and then 1.
Very good, -3 and +1. And there's no need to divide by anything because we didn't use the AC method to begin with, which would have required us to divide. But we didn't. So now, what is my next step to find my solutions?
You're going to set each of the solutions to 0.
Good. You're going to set each of these expressions equal to 0. And then you're going to solve each one of them. So that means that we cross the x-axis at these 3 values, which is consistent with the degree of the polynomial, which states we should have 3 zeros. Make sense? All right. Everyone feel good about GCF and AC method? All right. All right, moving on. Now we're going to do GCF and completing the square. So the original steps that we used before are the same. Our goal is to get everything to one side of the equation just like before. This leaves me with 3x to the 4th minus 6x cubed plus 12x squared is equal to 0. Now your goal here is to look for a GCF. Do we have one?
Yes.
What is it?
3x squared.
3x squared. We're taking out a 3x squared, and that leaves me with this. Everyone with me so far on that? How we got here? So here's where things get tricky. There are no factors of 4 that add up to -2. So this is where we have to start using alternate methods. So how we will typically do this is by what we call completing the square. So you're going to rewrite everything you have except for you're going to leave a bunch of space right here, okay? And you're going to put that last C value over here. So I do what we did before, but I'm basically just going to leave space here, okay? That space is going to be filled by the new C term that we create, okay? So here's how you do it. You're going to take whatever half of this number is and square it. What is half of -2?
-1.
Good. What's -1 squared?
1.
So I'm going to add 1. Now, normally, you can't go around just adding 1 to one side of the equation because it changes the balance of the equation, right? So usually, you would then add that same thing to the other side. But the problem with that concept here is we can't really do that because this is all tangled up in this multiplication. So there's another alternate way we can balance this equation back out. If I add 1 to something, say you gave somebody an extra dollar, how would you balance it out?
You would subtract it.
You would subtract it,
But also
exactly.
I have a question.
Sure.
I missed how you got to like 1, so you divided the 2x.
So I brought the all the terms over,
Mhm.
and then I factored out a GCF.
Yes, I remember that.
And that's all I did so far. Here,
How'd you get the 1 though?
oh, I got you.
Yeah.
So to find the 1, you take half of whatever this number is
Okay.
and square it.
Got it. Okay, that makes sense.
Okay? That's how you complete the square. All right, everyone with me so far on how we got to where we got to? Okay. So the goal with completing the square is the first 3 terms right here in the parentheses are going to factor, and the last 2 are going to be combined. Okay? So that's going to leave me with the 3x squared on the outside, and then we're going to have a double parentheses situation going on here. Combining like terms in the yellow is going to go here. And then what we get as the result of the factoring in the blue is going to end up here. All right? So what are some factors of 1 that would add up to negative 2?
Negative 1 and negative 1.
Very good. And here's a tip for you. Every time you complete the square, whatever half of this number was originally will always be what it factors into. Okay? And then what will the yellow combine to be?
3.
Good. Positive 3. Now, how can I rewrite 2 identical binomials as one expression?
Square.
Good. All right. So everyone with me on how we got to this point?
Yes.
Now, don't we have the product of 2 expressions here? The product of 3x squared and the product of x minus 2 or x minus 1 squared plus 3. So that means we can then use the zero product property, which states that we can set each product equal to the same thing we've been doing. Set it equal to 0. And now we solve. We divide both sides by 3. We get x squared is equal to 0. Are we done solving that equation?
No.
What do we have to do?
Square root.
Square root. When you take a square root, you always put in a plus or?
A minus.
Good. But the thing is 0 negative or positive?
It's neither.
It's neither. Which tells us we do end up with 2 solutions of 0. They are both just 0 though. Now, normally you would just think any other day, oh, well, we just have a solution of 0. Why does it matter how many times it occurs?
It's like the quadratic bounce thing.
Yes, exactly. So this is why we're adding in that extra step. Now that we've learned about multiplicity, we know that the number of times the 0 occurs actually does affect our graph, right? So this affects what's called the multiplicity of the graph, okay? That 0 occurred twice. So now we're going to solve the other one by subtracting 3 on both sides. That's going to give me x minus 1 squared minus 3. And then what would be our step to get rid of that square?
Square root.
Square root. X minus 1 is equal to, plus or minus, I radical 3.
Oh, right, because it's a negative 3.
It is a negative square root. And when you take a negative square root, you have to put the I there. And in this case, the square root of 3 does not simplify. Okay? So it's left as is.
So will we add the 1?
We would. Very good. So to finish this off, we're going to add the 1 to both sides. That's going to leave us with x equals 1 plus or minus I radical 3. This represents how many imaginary solutions? The plus and the minus indicates we have two solutions there, right? We have the negative and the positive version. So we have two imaginary solutions, right? And how many real solutions do we have? Two real. And they are the same, which means they have a multiplicity of 2. So with that information, what would the original degree of this polynomial be?
It would be 4.
Fourth degree. And is that what it was before we did anything to it?
I mean,
Did it have a fourth exponent on it?
oh wait, did it? Yeah, it did.
It did, right? So that's just like a little way to like check your work and ensure that you have received the number of zeros that is necessary for that degree. Okay? So we are actually going out and finding those imaginary zeros that yesterday we weren't able to identify by the graph, right? So we do have an algebraic way to find them. So any questions about this one?
So wait, for the GS and AC method, could you also find imaginary zeros to that?
Yeah, that's totally possible as well. It just so happens that we didn't. Wait, it depends. Not necessarily. Usually not imaginary zeros for AC method. You could for the other method we're going to do square root. Because with AC method that means it factors, and given that it factors, you're not going to have any imaginary zeros. So no.
That makes sense.
Yeah. Okay. So we'll try one more like this. First thing we do is look for a GCF. Do we have one?
X.
X.
Good. We're going to take out an X. Now, spoiler alert is there are no factors of 6 that add up to negative 6, so we know we're going to need to complete the square. So we leave space for our new terms. How do we find those new terms? Half of this number, right? Half of negative 6, and then what do I do with it?
Square it.
Square it. What's half of negative 6?
Negative 3.
Which square it is?
9.
9. If I add 9, I have to
Subtract 9.
subtract it to balance it out. So it seems silly to do that, but there's a reason that we do it. It's a tool. Okay, it's like a way to get things back to working. It's kind of like when you're driving on a street and like you need to go like right here, but it's a one-way street and you have to go all the way around to get back to it. It seems ridiculous, but it's the only way it works in that situation, which is exactly how this is as well. You have to add a 1 and then take it away, or add a 9 and take it away. So it's silly but useful. So these are going to factor into two identical binomials, and then this is going to become a negative 3. Everyone understand where the negative 3 came from? If it helps, I can highlight the colors to keep everything consistent here. Now, I'm going to have to factor that quadratic. What are factors of 9 that add up to negative 6?
Oh,
Negative 3, negative 3.
Very good. How can I rewrite two identical binomials? Very good.
X bar 3 squared.
And now I'm at the point of two products, so I can set each one of them equal to
0.
good. That first one was easy. There's no solving required.
And then you add the 3.
Good. We add the 3. And then what?
Then you would square it.
Square root it.
And then that would be, oh, that wouldn't be, what is that? It's not imaginary, it's not negative,
It's just plus or minus the square root of 3. Because if the square root doesn't simplify, you're just going to leave it as is. And then my last step to solve for x is to add the 3 over, right? Like that. So Is that an imaginary zero?
No.
It's real, but it's not rational. It's called irrational, right? So this happens, if you were to put this in the calculator, you would get a decimal approximation for it, which would tell you approximately where it crosses the x-axis. Now this right here represents two irrational zeros. So we have two real zeros from this one, and they are irrational. And over here, we have how many from this one? Just one real zero. And that one is rational, okay? Which means that from that information, what kind of polynomial did we have of degree what?
3. What happened to the plus 3? For the, don't you need 3 solutions?
We do have 3. This represents 2 solutions. This represents the solution x equals 3 minus radical 3 and x equals 3 plus radical 3.
So the 3 is just a thing you do to solve the. Okay, never mind. I got it.
Okay.
I got it.
Sorry, I just didn't understand the question.
No, I understand.
Okay.
That was really confusing what it said.
Does anyone have any questions about this one further, or are you good to go? Do you need more time on the slide? All right, I'll give you a little more time. Okay. So now we're going to talk about grouping. We've done grouping in the past. It's not a new thing. So let's explain a little bit about when you would use grouping. My pen's acting up right now. Hang on. So you know to use grouping when you have a cubic polynomial that is in descending degree order that doesn't skip any terms. You see how this one has the cubic term, the squared term, the x term, and the constant? That's when you know grouping is going to be the one that you want. Why is my pen doing this to me right now?
Because your pen doesn't like you.
There we go. I know it doesn't. Probably because I make it do math all day. But that's okay.
Yeah, that's probably the reason.
Probably it. So, with grouping, you're going to split this down the middle, okay? You're going to draw an imaginary, but really drawn line that exists, but not really.
Do you know it's down the middle because there's 2 terms on each side?
Exactly, yeah. There's going to be 4 terms when you use grouping. So then on the left, you're going to see if there is a GCF of those 2 terms. And what do you think?
X.
Very good. You're going to take out an x. And then over on the right, what can I factor out?
Shouldn't that be x squared, not x?
You're right. It is x squared. Thank you.
Yeah, I realized all of this.
We can do better than an x.
Factor out -3.
Good. We're going to take out a -3. Now, you might be asking yourself, why would we take out a -3 instead of a +3? Anyone remember why?
So you'd switch the sign?
What do you notice happens when I took out the -3?
It would always be the same.
They're the same, and that's that's pretty much the goal of factor by grouping. You need those 2 binomials to come out to be the same, okay? And then here's where people get a little confused. If I remove this line right here, we basically just have an equation x squared plus or times x plus 2 minus 3 times x plus 2. Now, think of these as 2 individual terms. Okay, we have one here and we have one here. What do these 2 terms have in common?
X plus 2.
So I can therefore factor the x plus 2 out of both of those individual terms. So I'm going to take the x plus 2 out, which leaves me with what?
X squared minus 3.
Good. And that is what you're left with.
Wait, how did you factor that out?
So pick a letter, any letter that you want.
A.
Okay, so I'm going to take x plus 2 and I'm going to replace it with a. All right? What can I factor out of this sentence here?
A.
So if I take out an a, I'm left with this. What is a actually equal to? no, you said earlier we set a to be equal to this, right?
Oh, yeah, right. So it would be that, so we'd like subtract one of them out? I'm confused.
You just factored it out. It just looks different than what you're used to factoring out.
Wait. I got it now, thank you.
Okay, you're welcome.
You're okay.
So, now what are we gonna do with those two solutions there?
Set them equal to 0.
Good. Set them equal to 0. And then solve. Square root, x equals plus or minus radical 3, which means we have two solutions. X equals radical 3 and x equals negative radical 3. So did we end up with 3 solutions?
Yep.
Are they all real?
Yes.
They're real, they're just some of them are
Irrational.
irrational. All right, what do you think about grouping?
Easier.
Easier? You want to try one more grouping?
I don't see why good.
Yep.
Okay, why not? All right, we'll do it. All right, let's try another grouping. So in this grouping, I need to bring over the 12. What's my next step in grouping? Split it down the middle. What can I factor out on the left here?
3x squared.
3x squared.
Which leaves me with this. What can I take out over here?
Negative 3.
See how we get the same thing on both sides now? When I do that? Which is what we want. We group together what's outside. And then what would my next step be? Set them equal to 0. I somehow changed this to a 3. It was originally a 2. Square root. We get x equals plus or minus 1, and x equals negative 4. So how do you feel about grouping? Is it easier, you think, than the other methods?
Yeah.
No.
What? How?
All right, we have one more thing to do today. We're going to skip 7 through 10 and come back to it because that's like a whole new topic that I don't want to do with so little time. So, we are going to skip 7, this whole section, and we're going to go to 11 and 12. Okay, so go to 11 and 12. Okay, so this is probably the easiest method of them all. This is square root method. And we use square root method by getting everything to opposite sides. Basically, you're going to leave just the variable on the one side. So you're going to subtract 4 on both sides.
So wouldn't it just be like square root for imaginary? Like it would be imaginary square root 4?
Yeah, pretty much. So you're just left with x equals plus or minus 4i. I mean, sorry, 2i.
Oh, right, because you can simplify 4 squared.
Correct.
Can I borrow your eraser?
Oh, yeah.
So those are my two solutions. Both of these solutions are what? Imaginary, right?
It just flew right off.
And the degree is 2. Is that consistent with what we have here?
Yes.
Okay.
Oh, yeah, right, I forgot you can check the degree.
You can check the degree and make sure you're right. And then the last one is pretty easy. Add the 4 over. You probably already know how to do these ones. Square root. 2x is equal to plus or minus 2. X equals 2/5 and x equals negative 2/5. 2 real zeros, which is consistent with what we have. So your only homework tonight is to do these 7 problems. Your homework for the following day will be to finish them. The reason it's super random is those are the few problems that don't require you to know 7 through 10, okay?